Hi, in this video we are going to see a problem on binomial expansion. Let's go over the question. Determine the fourth term in the expansion of x square negative 2a to the seventh power when written in descending order by degree of x. Okay, consider the general concept of binomial expansion, that is a positive b whole to the nth power. Okay, in this binomial expansion, the formula to find r plus 1th term is NCR a to the power n minus r, b to the rth power. Okay, comparing this a positive b whole to the nth power and x square negative 2a whole to the seventh power, we get a is equal to x square, b is equal to negative 2a, and n is equal to 7. Okay, now let's plug in these values for a, b, and n into this r plus 1th term. Then I'll be getting r plus 1th term is equal to 7cr, and a is going to be x square to the power n minus r. We have n is equal to 7, so 7 minus r. And for b, we have negative 2a to the power r. Okay, this is a formula we get for r plus 1th term in the given binomial expansion. So in this r plus 1th term, if I plug in r is equal to 0, I'll be getting the first term. That is, when I plug in r is equal to 0, you'll be getting 0 plus 1, that is t1. T1 represents the first term, which is 7c0. Because I plug in r is equal to 0, so 0 plus 1 is 1. X square, 7 minus 0 is 7, and negative 2a to the power 0. So this term x square over to the 7th power will become x to the 14th power, because we have to multiply the two exponents. Okay, now I'm going to plug in r is equal to 1. When I plug in r is equal to 1, I'll be getting 1 plus 1, which is t2. I'm getting the second term, which is equal to 7c. Here I'm plugging in r is equal to 1. So 7cr means it will become 7c1 x square. 7 minus 1 will become 6, negative 2a to the power 1. So this one will become x to the 12th power. So in this way, I can get the successive terms by plugging in r is equal to 2, 3, 4. So here from these two terms, from the first term and second term, so the degree of x is 14, the first term, and in the second term, the degree of x is 12. So it's getting decreased. That is, in descending order, it is going from greatest to least. So when I plug in r is equal to 0, I get the first term. When I plug in r is equal to 1, I get second term. In this way, if I want to get the fourth term, I must plug in r is equal to 3. Because if I plug in r is equal to 3, 3 plus 1, 4, I'll be getting fourth term. And also the terms, the degree of x is in descending order. Okay, so to get the fourth term, I have to plug in r is equal to 3 into this formula. Okay, let's plug in r is equal to 3. Then I'll be getting 3 plus 1, 7c3, x square whole to the power of 7, negative 3, negative 2a whole to the power of 3. So let's evaluate the value of 7c3 separately. So 7c3 is equal to 7 into 6 into 5 over 3 into 2 into 1. So 3 times 2 is 6, 6 will cancel out, we get 35. So the value of 7c3 is 35 times x square whole to the power of 4. And when 3 is a common exponent for negative 2 and a, and these two terms, negative 2 and a, are in multiplication. When I have the common exponent, when I take this exponent 3 separately for each term, that is for negative 2, there is negative 2 whole to the power 3 will become negative 8. When I take this 3 for a, it will become a cube. So in the next step, I can multiply this 35 and negative 8. So which is going to be negative 8 times 3 is 24, 240. 8 times 5 is 40, 280. And when I multiply these two terms, it will be x to the 8th power a cube. So the fourth term, when I write the terms in the expansion by writing the degree of x in descending order, the fourth term is going to be negative 280 x to the 8th power a cube.